Um, Projectന്റെ PPT upload ചെയ്തോ?
അത് എവിടെയാ മിസ് അസൈൻമെന്റ് പബ്ലിഷ് ചെയ്തേ?
നിങ്ങൾക്ക് സാധാരണ അസൈൻമെന്റ് പബ്ലിഷ് ചെയ്യുമ്പോൾ സബ്മിറ്റ് ചെയ്യില്ലേ നേരത്തേക്ക്?
അവിടെ കണ്ടിട്ടില്ലല്ലോ മിസ്.
നോക്കട്ടെ, ഞാൻ നോക്കാം. PPT റെഡിയാക്കി വെക്കും കേട്ടോ. റെഡി ആയിരുന്നല്ലോ അല്ലേ? കറക്ഷൻസ് പറഞ്ഞതെല്ലാം ചെയ്തിട്ട് അപ്ലോഡ് ചെയ്യാൻ റെഡിയാക്കി വെക്കാം.
ആ മിസ്.
Okay, yesterday we were discussing about UML and how we can model the structure and behavior of a system using UML. UML full form and what is the full form of UML? Vishnu P. Vishnu,
Oh,
what is the full form of
that
UML?
unified modeling language.
Unified modeling language. So we were discussing about unified modeling language yesterday. Yesterday and day before yesterday, 2 3 classes we were speaking about UML, the basic building blocks of UML, and then how you can model the structure and behavior of software or embedded systems using UML. And there are different diagrams. A total of basic diagrams there are 9, and one more additional diagram, package diagram, was also included. So a total of 10 diagrams can be used for modeling the different views of a system. And I said there are 5 basic views for a system. Uh, do you remember what are the views? What are the different views of a system? Any software system has we can view it from different viewpoints, and there are basically 5 views. One is use case view, then process view, design view, implementation view, and deployment view. All these views can be represented using UML diagrams, and a single system needs all these views. To implement a single system, you have to specify all these views, because use case diagram has a particular objective, like capturing the requirements of the system, whereas design diagram shows only the design of the system, implementation view shows only the implementation part. So all these views combined together will form the entire system. So, and we discussed about how you can draw these diagrams, like the sequence and collaboration diagrams, etc., which we have studied earlier in S4 also. So now we are going to the second module. So I'll present the screen now. Okay. Can you hear me? Hello, can you hear me? Okay, okay. So we are going to the second module, and I'm just going to give you an overview of what are the topics included in second module. So the main focus of second module is on co-design process, that is hardware, software, co-design and program modeling. This is the basic topic that we are going to cover. In the first section, we will cover the hardware software co-design process, and then how next section we will cover the various methods, modeling techniques for a particular program. So, what is hardware software co-design, and what was the traditional approach for designing? So, this module mainly focuses on how the embedded system is going to be designed. How are you going to design an embedded system? So there are different approaches for designing an embedded system. So basically there was a traditional approach for embedded system design, and there is a novel approach. So for designing an embedded system, before we implement an embedded system, we have to design the system. Just like before you are going to implement your project, you have completed your design in the last phase. Here also we are going, before going to implement the embedded system, or before going to develop an embedded system, we have to first design the system. Only with the design is perfect, then we can correctly implement the system. So design tells us everything that has to be implemented in a system. So if the design is perfect, then it can be automatically translated into implementation. So design is an important step in most of the software as well as embedded system development process. So how can we do? So this module, entire module covers the design of an embedded system. So and here as I've said in the definition earlier itself, in the embedded system definition, it is a combination of hardware and software. Software in embedded system we call it as firmware, because it is designed for a specific hard purpose, and it is not alterable by the end user. If a software is designed for a specific purpose, and if it is not alterable by the end user, then that particular software is called a firmware. Then this cannot be changed. Once it is written, it is, and when it is, if it is, when it is embedded into, after embedding it into the system, you cannot change the software. Like in washing machines, you might have seen the software cannot be changed. We are just giving an input and getting the output. The program inside is running as it has been designed earlier. So here also we have to design software part as well as hardware part for an embedded system. For software intensive systems, we have only software part, but for an embedded system, we have software design as well as hardware design. And finally, after designing the software and after designing the hardware, how are we going to integrate the software and hardware? They should work together. Only then we will get the desired functionality. So to design software and to design hardware, embedded systems had followed two approaches. In the earlier days, the approach used was what we call it as the traditional embedded system design approach, and now we are changing the traditional approach and we are following another approach, or the new design approach, and that is called hardware software co-design process. So that is the main focus of this module. Our main focus is not on the traditional method, but the novel method of co-design process, that is hardware software co-design process, is the new approach. There was a traditional approach, but that has several drawbacks, and we are going to discuss about the traditional method, its drawbacks, and after discussing the drawbacks we will go to the new method. And that new method of embedded system design is called hardware software co-design process. Can you understand what I'm saying? Hello, can you understand what I'm saying? Okay. So to design an embedded system, we have to design both the hardware as well as software, because the software designed for the particular system called firmware, it is embedded in the hardware. So both has to be designed in order to make the system function properly, or to get the desired functionality, or to get the desired output. Both software as well as hardware should be perfectly designed. And how are we, what are the methods used for designing? And that is what we are going to say. There was a traditional approach, and in traditional approach, the hardware and software partitioning is done at an early stage. That is, initially when we start, before implementation, we design the system, and during the early phase of design, the designers, they will first partition the system into hardware part and software part, and then the hardware team will is responsible for building the hardware required for the system or the product, and the software team is responsible for building the software architecture and its development. So two teams will be working for in the design process. One is the hardware team and the other is the software team. Hardware team is solely concerned with developing the hardware part of the system and designing the hardware part of the system, whereas the software team takes care of the software architecture. Software architecture is the blueprint for the system to be developed, for the software to be developed. So after building the software architecture, we can directly write the program. Software architecture serves as a blueprint for the system to be developed. So the software team takes care of the software part, the hardware team takes care of the hardware part, and there is less interaction between these two teams. The two teams, they do not interact with each other much. That is the traditional approach. Hardware team just focuses on what are the hardware required for the system, and they will design their hardware. And software team is responsible for developing the software part of the system, and then the development happens either in serial or in parallel. Serial means after hardware development, after the design of hardware, software design takes place. That is serially one after the other. And in parallel means they are hardware and software. The design is carried out simultaneously. So the development can be either serially or happen serially, or it can happen parallelly. And finally, when both the teams have designed their software, the integration is performed when both hardware and software is ready. After the design, they implement they write the software program. Software designers write the software program. Hardware designers, they integrate their hardware units, and finally, this software is put into the hardware and integrated. That is called integration. Uh, Embedding the firmware into the hardware is called integration, and this integration is performed, and then finally it is tested. So these teams, there was less interaction between the two teams in traditional approach, and there were several drawbacks. As you can understand from the points itself, we can say there will be several drawbacks because the teams are independently working, and there is less interaction between the teams. So when the software is put into the hardware, there is a chance of large amount of errors to be uncovered. And so those disadvantages are being stated here. That is, there was uh, when hardware and software, when they are designed separately, it may consume a lot of time, and this will increase the time for the product to enter the market. And so there was reduced time to market. That means once this product is taking a lot of time to enter the market, other products may emerging, maybe getting ready, and there was a tight competition among other products. And if this product is getting delayed, then the time to market also gets reduced, and by the time it enters the market, the product might have become outdated. And so it was traditional approach was consuming a lot of time, and so there was reduced time to market, and this inhibits this approach. And we cannot follow this approach because the product will not be successful if there is reduced time to market, or if it is taking a lot of time for development. Then this reduced time to market, we should consider the reduced time to market mainly because there was increased competition in the commercial market. So similar products, many products with the same functionality manufactured by different companies will be emerging. And if a particular company fails to enter the market at the correct time, then their product might be lagging behind, and it may not be profitable for the company. So this traditional approach was time consuming, and there was reduced time to market because of increased competition. If there is reduced time to market, then the product cannot survive in the market. So these are the disadvantages of traditional approach, mainly because the time taken was too high to develop a product. So the disadvantages of traditional approach has been listed here, and now to overcome this disadvantage and to make the product to reduce these disadvantages and to improve its functionalities, or to make it affordable. Like we should enter the market at the right time before any other products, similar product, and also to make it possible. The traditional approach was not followed in the later days, and finally there was a new approach for designing was adopted, and novel means a new approach for embedded system design has been adopted, and in this approach hardware and software are co-developed. Co-developed means they are developed as hardware is getting ready, the software also gets ready, and it is getting tested along with the hardware. So it is getting co-developed instead of independently developing both. In traditional approach, we said hardware developers are responsible for developing the hardware, the software developers are responsible for developing the software, and finally, when both are ready, they are integrated. At that time, there can be a lot of errors, and this will increase the time to build the product, and that thus reducing the time to market. So, in novel approach of embedded system, those drawbacks were abandoned, and in this approach, hardware and software are co-designed instead of independently developing both. And this process of co-design is called the co-design process, the hardware-software co-design process. So hardware, the new approach for embedded system design is called the co-design process or the hardware-software co-design process. Now, what is this co-design process, and what are the steps in co-design process? That is what we are going to continue. Are you understanding what I'm saying? Hello. Okay, Anishni. Now, Ashwin, what is the novel? What is the novel approach for embedded system design? What do you call that process? The novel approach or the new approach for embedded system design. What is that called? Arjun is not there. Ashwin? Can anyone say? What do you call the new approach of software embedded system design process? Can you name that process? The novel approach for embedded system design is called what? Nobody is answering. നിങ്ങൾക്കപ്പോൾ മനസ്സിലാവുന്നില്ലേ പറയുന്നത്? വിഷ്ണു, വിഷ്ണു പി.
പറഞ്ഞോളൂ.
ആ വിഷ്ണു മനസ്സിലായോ ഞാൻ എന്താ പറഞ്ഞതെന്ന് ഇത്രയും നേരം?
ഇതിനെ പറ്റിട്ട്
ആ
രണ്ട് പാർട്ടാക്കി ഇരുന്നിട്ട് ഒരാൾ
ആ
ഇതിനെ പറ്റി വർക്ക് ചെയ്യും, മറ്റൊരാൾ ഡിസൈൻ ചെയ്തല്ലോ. ഇപ്പൊ എറർ
ആ
മറ്റേ ഒരാളുടെ ഡിസഡ്വാൻറ്റേജ് ഒന്ന് എറർ വന്നാല് സോൾവ് ചെയ്യാൻ വിഷമായിരിക്കും അങ്ങനത്തെ.
അത് വെച്ചാൽ ഡിസൈനാണ്, ഹാർഡ്വെയർ സോഫ്റ്റ്വെയർ ഡിസൈൻ പ്രോസസ്സിനെ കുറിച്ചാണ് നമ്മൾ പറഞ്ഞുകൊണ്ടിരിക്കുന്നത് അല്ലേ. അപ്പോൾ ഡിസൈൻ ചെയ്യുമ്പം എംബഡഡ് സിസ്റ്റത്തിന് രണ്ട് പാർട്സ് ഉണ്ടെന്ന് പറഞ്ഞു, ഹാർഡ്വെയറും ഉണ്ട് സോഫ്റ്റ്വെയറും ഉണ്ട് അല്ലേ. അപ്പോൾ ഹാർഡ്വെയർ എക്സ്പേർട്സ് ആയിരിക്കും ഹാർഡ്വെയർ ഡിസൈൻ ചെയ്യുന്നത്, സോഫ്റ്റ്വെയർ എക്സ്പേർട്സ് ആയിരിക്കും സോഫ്റ്റ്വെയർ ഡിസൈൻ ചെയ്യുന്നത്. പക്ഷെ രണ്ടുപേരും ഇൻഡിപെൻഡൻ്റ് ആയിട്ട് ഡിസൈൻ ചെയ്യായിരുന്നു ട്രഡീഷണൽ അപ്രോച്ച്, പഴയ അപ്രോച്ച് എന്ന് പറയുന്നത്. അപ്പോൾ രണ്ട് അപ്രോച്ചിനും ഇൻഡിപെൻഡൻ്റ് ആയിട്ട് ഡിസൈൻ ചെയ്ത് കഴിഞ്ഞാൽ ഇത് ഫൈനലി ഇൻ്റഗ്രേറ്റ് ചെയ്യുമ്പം ലോട്ട് ഓഫ് എറർ വിൽ ബി അൺകവേർഡ് ട്രഡീഷണൽ അപ്രോച്ച് അനുസരിച്ച്. സോ അതിന് പകരമാണ് ന്യൂ അപ്രോച്ച് വരുന്നത്. ആൻഡ് വോട്ട് യു കോൾ ദറ്റ് ന്യൂ അപ്രോച്ച് എന്നാണ് ഞാൻ ചോദിച്ചത്. ന്യൂ അപ്രോച്ച് എന്ന് പറഞ്ഞാൽ ഹാർഡ്വെയറും സോഫ്റ്റ്വെയറും ഒരേ സമയത്ത് ഡെവലപ്പ് ചെയ്യുന്നതിനനുസരിച്ച് ഹാർഡ്വെയറിൽ ടെസ്റ്റ് ചെയ്ത് പോവുകയാണ്. അവസാനം കൊണ്ടുവന്ന് ഇൻ്റഗ്രേറ്റ് ചെയ്യുന്നതിന് പകരം ഡെവലപ്പ് ചെയ്യുന്നതിനനുസരിച്ച് ടെസ്റ്റിങ്ങും നടന്നു പോവുകയാണ്. അപ്പോൾ അതിന് എന്താ പ്രോസസ്സിനെ പറയുന്ന എന്താ പേര്? പുതിയ അപ്രോച്ചിനെ പറയുന്ന പേരെന്താ? There was a traditional approach where they were independently developed, hardware and software were independently developed. But in the new approach, they are both developed together. And what do you call that process? എന്നാണ് ഞാൻ ക്വസ്റ്റ്യൻ ചോദിച്ചത്. പുതിയ അപ്രോച്ചിൻ്റെ പേരെന്താണെന്ന് ചോദിച്ചു. The novel approach for embedded system design. It is called the co-design process, hardware, software co-design process. Co-design എന്ന് പറയുന്നത് co-developed, co-design എന്നൊക്കെ പറയുന്നത് ഒന്നിച്ച് ഡെവലപ്പ് ചെയ്യുന്നതിനെയാണ് co-design അല്ലെങ്കിൽ co-development എന്ന് പറഞ്ഞാൽ ഒരേ സമയത്ത് ഡെവലപ്മെന്റ് നടക്കുന്നതിനെയാണ് co-design co-development എന്ന് പറയുന്നത്. സോ നോവൽ അപ്രോച്ചിൽ co-design ആണ് നടന്നിരുന്നത്. ഇൻസ്റ്റെഡ് ഓഫ് ഡിസൈനിങ് ഹാർഡ്വെയർ ആൻഡ് സോഫ്റ്റ്വെയർ സെപ്പറേറ്റ്ലി, they was designed together, and that is called the co-design process. And the co-design process, ഇതൊരു ഇമ്പോർട്ടൻറ്റ് ക്വസ്റ്റ്യൻ ആണ്, യൂണിവേഴ്സിറ്റി ക്വസ്റ്റ്യൻ ആണ്. 4 മാർക്സിന് ചോദിക്കാം, എസ് എ ആയിട്ടും ചോദിക്കാം. എസ് സി ആയിട്ട് ചോദിച്ചാൽ നിങ്ങൾ ബ്രീഫായിട്ട് വലുതായിട്ട് എഴുതണം. അതിൻ്റെ സ്റ്റെപ്സ് ഒക്കെ കൊടുത്തിട്ടുണ്ട്. ബട്ട് യൂഷ്വലി 4 മാർക്സ് ആയിട്ടാണ് ചോദിക്കുന്നത്. പക്ഷെ ഇതിൻ്റെ കൂടെ ഒരു ക്വസ്റ്റ്യനും കൂടെ വരാം. വാട്ട് ആർ ദി ഇഷ്യൂസ് ഇൻ co-design? 2 ക്വസ്റ്റ്യനും കൂടെ വരുമ്പോൾ ഇത് എസ് എ ആയിട്ട് വരും. സോ ദ co-design process. So the co-design process is done in 2 stages. Co-design 2 parts ആയിട്ടാണ് co-design process നടക്കുന്നത്. അതിൽ ഫസ്റ്റ് സ്റ്റേജ് is called the system design and the second stage is called architectural design. So there are 2 stages in the co-design process. The first stage is called system design and the second stage is called architectural design. ഈ സ്റ്റേജസിലൊക്കെ എന്താണ് ഇനി ചെയ്യാൻ പോകുന്നതെന്നാണ് പറയാൻ പോകുന്നത്. ഫസ്റ്റ് സിസ്റ്റം ഡിസൈനിൽ എന്തെല്ലാം കാര്യങ്ങൾ ചെയ്യുന്നുണ്ട്, ആർക്കിടെക്ചറൽ ഡിസൈനിൽ എന്തെല്ലാം ചെയ്യുന്നുണ്ട്. ക്ലിയർ ആവുന്നുണ്ടോ? Hello. So what are the stages in co-design process? How many stages are there and what are the stages in co-design process? There are 2 stages. Okay, Harida, what are the 2 stages? ഇതൊക്കെ സിമ്പിൾ ക്വസ്റ്റ്യൻസ് അല്ലേ? ശ്രദ്ധിച്ചിരുന്ന ജസ്റ്റ് കേൾക്കാൻ അറിയാൻ പറ്റുന്നല്ലേ ഉള്ളൂ. എല്ലാം തിയറിയാണ് ഇപ്പോൾ പറയുന്നതെല്ലാം. First stage is called system design and the second stage is called architectural design. Okay, architectural design. So there were 2 stages in the co-design process. One is the system design and the second stage is architectural design. So now what is system design and what is architectural design? So system design is developing the various functionalities of the system. System design deals with developing the functionalities of the system. So the steps in system design, you have different steps in system design. Basically 4 steps are there in system design. Adil first step ennu parayunnathu, the first step is the product requirements. As we know in software engineering also, the customer will approach you to develop a software. So what the developers do is they discuss with the customer and collect their requirements. That's the first step, because we have to know what the customer wants, what the customer intends to be implemented in the product. So we have to collect the requirements from the customer, and that is the first phase in software engineering, that is requirements analysis. And here also we have to collect requirements from the customer, because customer is the person who approaches the developer to build a product. So the developers will have to ask the customer what they want, what are the functionalities they intend to implement. So the first step is always discussion with the customer and collecting the requirements from the customer. So the system design, the first step in system design is here, since we are going to develop an embedded system, it will be a product, a final product will be developed. So the product requirements, that is what are the functionalities that should be implemented in the product, they are called product requirements. The product requirements requirements are first captured from the customer. It is the customer who approaches the developers to build a product. So the developers will consult, will discuss with the customer and collect all the product requirements. So embedded product requirements means the functionalities that should be implemented in the system. In the first module, we said requirements are of two types: functional and non-functional requirements. In software engineering also you have studied requirements are of two types: functional requirements and non-functional requirements. So all these requirements are collected from the customer. The customer may not be able to explain the non-functional requirements, but they will be able to explain the functional requirements. That is, what are the functionalities that can be satisfied, that they want to be built in the product. So the first step is the product requirements are first captured from the customer. So next step, they are then converted into system level needs or processing requirements. So once the customer details are collected from the customer, the developers then convert these requirements, that is the requirements, product requirements, into system level needs. That is, what are the system functionalities that can be implemented in the system, or we call it as processing requirements or functional requirements. So that's why I said before, requirements can be either functional requirements or non-functional requirements. So once they collect the product requirements, they convert it into functional requirements. And this functional requirements can be either hardware functional requirements or software functional requirement, but it is not separated here. They're considered as functional requirements only, whether it is hardware or software. It is not partitioned as hardware or software requirements, but they are grouped as functional requirements or system level requirements, or it is also called processing requirements. So the product requirements from the customer is first converted into system level requirements, or you call it as processing requirements, or it is also called as functional requirements, but it is not separated as hardware or software requirements. Still, we are developers are not bothered whether it is a hardware requirement or software requirement. Then they go to the third step, and in the third stage, these requirements, they're transferred into functions that can be simulated. Like there can be testing tools or simulators for checking the requirements. So these requirements are transferred into functions that can be simulated and verified for performance and functionality. They have to check whether the functionality is satisfied, whether the performance is satisfied. So there are several tools assist in this process. Several integrated development environments, simulators, emulators, etc. are used for this stage. And these are the processing requirements or the functional requirements, they are transferred into functions which can be tested and verified. Then the fourth step is some of the function. Now, after developing the functions that can be built into the system, now the last step is partitioning it into hardware and software functions. It is the functionalities that are being split into hardware functions and software functions. So some of the functions, they may be purely hardware functions, some of them may be software, built by software. So some of they are now the functions are then partitioned into, or they are mapped into hardware, and some of the functions will then be mapped into software. Anyway, the product requirements, so the first step is to collect the product requirements from the customer, and then these requirements are transferred into functional requirements, or processing requirements or system level requirements, and then it is transferred into functions which can be simulated by some hardware or software system, and it can be checked for functionality and performance. And then finally, after simulating the requirements, transferring the requirements into functionalities, some of the functions are mapped to hardware and some of the functions are mapped to software. It is at this stage that hardware and software functionalities are distinguished. And then with this, the first stage comes to an end. That is, the system design comes to an end. So at the end of system design, the developers will have certain functions that are mapped to software and certain functions that are mapped to hardware. Now, the second stage is the architectural design. In the architectural design, actually it follows the system design. This happens only after system design, and based on the hardware software trade-off, that is, there are certain trade-off between hardware and software, like cost performance, etc. And the system level processing requirements are then partitioned into hardware processing requirements and software processing requirements. So it is in hardware, in architectural design, that the system level processing requirements which was collected in stage 1, here we have said about system level processing requirements, and these system level processing requirements are converted into certain functions. These system level processing requirements are partitioned into hardware processing requirements and software processing requirements. So hardware processing requirements, it results in the detailed behavior of hardware requirements which are captured and these hardware requirements, that is the hardware units that are required for building the embedded product are captured in the hardware processing requirements. And to show it diagrammatically, anyway, design will be designed to design a system. You need certain diagrammatic representations, and these diagrammatic representations usually followed is the computational models, and the hardware requirements are transformed into computational models, and these computational models are nothing but design diagrams. These, looking at the diagrams, they can be directly translated into hardware. And hardware processing requirements are transferred, are captured in certain design diagrams called the computational models, and from the computational models they can be translated into hardware. And next, the software processing requirements, it defines the software required for the hardware to function. So it is also captured in computation. So computational models are nothing but design diagrams. Using these computational diagrams, computational models, we can implement the software processing requirements, as well as we can represent the software processing requirements as well as the hardware processing requirements. So software processing requirements defines the software required for the hardware, and they are captured in the computational. Captured in computational model means they are represented using computational model diagrams. There are certain diagrams that come under computational model, which will be covering in the next section. And this diagram can then, these computational models can then be translated into firmware, and this firmware can be implemented using a programming language. You need to write a software, you need a programming language. Like firmware is also a program, so you need some programming language to implement the firmware. And so these are the two uh, in the system level stages, that is two tasks that are done in architectural design. One is hardware processing requirement, capturing the hardware processing requirements, and the second is capturing the software processing requirements. The hardware processing requirements are captured and it is translated into computational models, and from these computational models it is then translated into hardware. Likewise, software processing requirements are also captured in computational models, and from the computational models they are translated into firmware, which can be implemented in a programming language. So both these requirements, whether it is hardware requirement or software requirement, both are captured in computational models, and these computational models are then translated into hardware, or it is translated into firmware. Hardware processing requirements will be translated into hardware, and software processing requirements will be translated into firmware. So these are the two stages in hardware software co-design process. The first is system design, second is architectural design, and system design has 4 steps, and architectural design has 2 tasks. One is capturing hardware processing requirements, next is capturing software processing requirements. Hardware processing requirements are finally translated into hardware, and software processing requirements, both are captured in computational models or their design diagrams. Finally, from these design diagrams, the implementers develop hardware or firmware required for the system. So these are the two systems, the 2 stages in hardware software co-design process. And there is a next, okay, we'll stop with this. Next, we'll have to discuss the issues regarding this co-design process. There can be drawbacks, as I said earlier, traditional approach has some drawbacks. Likewise, the novel approach also has some issues in development. And what are the issues in hardware software co-design process? So we'll cover that in the next class. Now take your attendance, please. Roll number 1, Abhilash A,
Present.
Abhinav Chandran, answer. Roll number 5, roll number 6, roll number 7, Roll number 8. Roll number 9. Roll number 11. Roll number 11. Roll number 11, are you present? Roll number 11. Absent. Atul Satyavan. Absent. Roll number 12. Roll number 12. Absent. Roll number 13. Roll number 14. Roll number 16. Roll number 17. Roll number 18. Roll number 18. Roll number 20. Roll number 20. Ramesh. Absent. Roll number 20. Roll number 22. Roll number 22. Absent. Roll number 23. Roll number 22 present. Oh no. Okay. Roll number 23 present. Roll number 24. 26. 27. 28. 29. 30. Roll number 30. Amrita P. Absent. Amrita. Ashwati Sir. 31. Roll number 31. Ashwati C. Present. Okay. Dijna. 32. Roll number 32. Roll number 32. Dijna, unmute ചെയ്യാലോ. ഇതിനെ ഇവിടെ കാണിക്കുന്നുണ്ടല്ലോ. ആബ്സെന്റ് മാർക്ക് ചെയ്തിട്ട് ഇവിടെ ഇല്ലല്ലോ ഇപ്പൊ ആള്. മീറ്റിംഗിൽ കാണിക്കുന്നു ബട്ട് പ്രസന്റ് പറയുന്നില്ല. ജിതിന. ഹരിത. അമൽ സന്തോഷ്. Okay. Absentees, roll number 11, 20, 30, and 32. Okay, thank you. Okay, Jidina present.